would say that understanding is a loaded term, and in the end, this might come down to something very fuzzy. But I do feel, as a researcher who thinks about linguistic meaning, that we can ask whether models have induced a semantics, which would be a true mapping from forms to something like concepts. And I think we are seeing a lot of evidence that these models are inducing a mapping from linguistic forms to concepts as we recognize them as humans. And that's fascinating, and that does suggest to me that they are on the road to true understanding. What that's going to do is make their behavior increasingly systematic. It does not imply that their behavior will be more trustworthy any more than it implies that people are going to be invariably trustworthy just because they have a semantics. These are orthogonal questions, but it does mean that their behavior is going to be increasingly human understandable for us. And I think in a way that I think will benefit all of us. And I want to say that one key ingredient for this that's a shift from that blog post you mentioned is that clearly models today are trained on much more than just text. They're trained on symbol streams that have sensor information and code and metadata, and you name it, right? And as a result, models are able to learn associations between the linguistic parts of their inputs and those other non-linguistic pieces that kind of might collectively express something like concepts. That's really crucial because I think text is a very strange, very partial reflection of the world we live in. But once you start to bring in all of that other information, it might be a very semantically rich space. And I think that might be part of what's unlocking the capacity of these models to be so apparently meaningful. Because there are lots of hidden premises in the assumption that just because humans learn in one way, these models to achieve the same end state as humans need to learn in the same way. That's obviously faulty. And it might be the case that large language models are different enough from us that they require different kinds of learning regimes, but nobody has shown me that the end state couldn't be the same qualitatively, for example, which would mean that these models really do use language in a meaningful way. You need to fill in lots of premises to get there. For the Noam Chomsky article, that was kind of shocking to me because he picked a lot of examples that mainly involve syntax. And the slam dunk for these models is that they have absolutely learned a lot of the causal structure of the forms of our language. I mean, that's the kind of thing that they were inducing just from self-supervision on not even especially large corpora. The hard part is learning the mapping from forms to meanings and really understanding the world that we live in. And I just want to be clear, they continue to fall down at that job. It's just that I have some conviction based on experiments we've done that we're kind of on a path to them having that very rich semantics. But the syntax part that Noam Chomsky was talking about, that happened a long time ago, in relatively speaking for AI, by which I mean like 3 years ago. I would just observe for your audience that the handling of corner cases has changed dramatically over the years in AI. It used to be that they were handled the way programmers handled them, which is that you would write a bunch of conditionals. And as you discovered these corner cases, you would handle them in some particular way. That really shifted in the era of machine learning. But still in the early years of that shift, the way you handled corner cases was by writing down some code that would create some features that would, you hoped, handle those edge cases. As we moved into this era of unsupervised learning on unstructured text and large language models as we know them now, the handling of corner cases became less strategic. Really now people just hope that the training data and the training regimes cover all of those cases. And I think what we're discovering as people launch these products is that even though the internal teams presumably worked hard to look for places where the model would fail, the public is more creative and finds more corner cases. And so they do arise. And we think of them as, the long tail of unusual inputs that lead to truly surprising and sometimes shocking outputs. And that problem persists. The one thing I will say is that we have a little bit, well, maybe significantly moved beyond the self-supervised paradigm that I was talking about in that blog post. I really had in mind models that were trained only on distributional data, but it's very clear that our best models, by and large, right now, are also trained with what's called reinforcement learning with human feedback, where humans directly express preferences about what good outputs are given some inputs, and express preferences about how to rank different outputs. And that takes us way beyond self-supervision and into the classic mode of AI, where most of the intelligence is in the end being expressed by humans so that we can help these models out. And the fact that that's so transformative that even small amounts of it seem to improve models significantly is really eye-opening, but it also kind of shows that it's not magic. It's not that somehow from just this raw distributional data, they induce these complex behaviors. Rather, they needed a lot of help from pretty smart humans. Let me push back a little bit, though, on the idea that they're making fewer errors. I'm not so sure about that. I think that just take a simple technology that we all probably still depend on, something like detecting spam email. At this point, those models make very few errors, right? Probably compared to what these current large language models are doing, they make vanishingly few errors. We are asking a lot of our language models, and I think as a result, they're going to make lots more mistakes. The thing that comes to mind for me is just how poorly all of these public models are doing at grounding their own responses in evidence from the internet. Web search is kind of a solved problem, and there are ways to combine web search with the output of these models, and yet still what they constantly do is hallucinate evidence for their own claims. They produce links that don't go anywhere, and they reference papers that have essentially nothing to do with the claim that they made. And these are all very serious mistakes. In fact, I would say that it's more severe that they're producing faulty evidence than when they were producing no evidence at all. Because when people see a link or see a link to a paper, they might assume without checking that that means it's grounded in some factual information, when in fact, all of those things might have been made up by the language model. I actually believe that this is a coming societal problem. Unless these public APIs really change and become more properly grounded in the web, so that at least users can check first order, is this actually in a document with a URL that I can then think about? We're going to have a real problem of false information being spread more rapidly than ever. The retrieval augmented one I mentioned, that's a growing societal problem. It is remarkable to me that large companies have deployed these models without having the ability to control their outputs to even be grounded in the web. Right? It doesn't need to be factual information, just documents that actually exist. And so a major challenge for the field is getting control of these models so that we could plausibly say that we have a knowledge store, our index of the web or whatever, and we have this language model, which is a language capability, and we're able to prevent the language model from going outside of its knowledge store. It should produce answers that synthesize actual information. And I think that retrieval augmentation is the kind of step zero in that process. A lot of work needs to be done, but all these models should be properly retrieval augmented. My very wise PhD student, Omar Khattab, who's, a visionary when it comes to this retrieval augmented stuff, he observed recently that we've moved into an era in which kind of, exploring a model is easy, right? You might just use GPT-4, but figuring out whether the model is succeeding at your task is very hard because we don't have the measurement device. And what you're seeing is, because these APIs are everywhere and people are exuberant, they try a few cases, they forget about all the failure cases, they tweet about the positive cases, and then we have an impression that they can do something. Very often, I have an intuition that when we do the rigorous thing, even just testing on systematically created examples that we agreed upon ahead of time, we find that their performance is pretty middling. And that just shows you that we as a research community need to get better at building these benchmarks and better at spreading the word that these models are not invariably successful. If we can't measure something reliably, or if we're measuring it unreliably without thinking about it, we're distorting absolutely everything. And so I could pair the benchmark thing with just making sure that we have metrics that are meaningful. I've complained about this before. We have all these estimates of human performance for all of these benchmarks we've created, but they have essentially nothing to do with human performance. We're having people do machine tasks and then saying it's human performance. And that is also just systematically misleading. The bright part about this is we've moved into an era in which we could do evaluations that were much more meaningful and really much more at the level of whether we're, for example, helping a user with a task they want to perform, and not just checking to see whether the model was better at assigning some labels than humans were. Nice case, in NLP, many of our examples are ambiguous because people just vary in their interpretations of language. So what we do now is pick some label that we call the correct label, and then we say that humans have fallen down on the job when they disagree on this point, when we actually know full well that the human disagreement is real, and that the human thing to do would be to discuss and debate and come to some terms about what the right label should be. And the models we were talking about until recently had absolutely no capacity to do that. And so we were just being unfair to the humans in these tasks by and large. But notice we're moving into an era in which discussion and debate could at least seem to take place, and we could bring that into our evaluations if we wanted. The metaphor here is kind of like, well, here's even more poetic. What we do with AI is get to the base camp of Everest and then perpetually claim that we are at the top.
Yeah.
Just because we got 95% of the way from sea level to base camp does not mean we scaled Mount Everest. And, for essentially every application that's going to involve humans, that last bit is incredibly difficult. That might be where all of the expertise and all the learning has to happen. And you see this time and time again, that people deploy things assuming the AI was going to take them to the top, and it doesn't even come close. And I think the issue is that it's not narrowly an AI problem anymore. For that last bit, you're talking about people and domains and interfaces and all of that other stuff that really embraces much more of humanistic aspects of this, product design, human-computer interaction, and then, of course, being grounded in whatever domain you're trying to have an impact in. The pattern that I've noticed is that it's very hard to be technology first. If you're just an AI practitioner and you think, I've got this powerful idea or this powerful model, I'd like to change the world with it, very often you're stuck at that point, because what you needed is to begin with an actual problem that needed to be solved, and then possibly find a way that AI would help you solve it. But if you begin from your problem, you might realize that, a lot of the problem is interfaces or data or something like that, that really has almost nothing to do with the model that you chose at the start. I do feel like that is our best chance of getting control of these models, figuring out what kinds of internal mappings they've learned from forms to meanings, and just in general, more deeply understanding how they're going to behave when they're given new inputs. In a way, the problem facing everyone who's deploying this technology is that they did some behavioral tests with examples they could think of, and then they put it out in the world, and the range of examples their system encounters is much wider and more varied and more surprising, and the model in turn does surprising and sometimes shocking and awful things. And this is because no amount of behavioral testing could give you a guarantee about what was going to happen on new inputs. The best hope we have is to deeply understand how these models work internally. And that's the project of explainability. And I think it's not a panacea, but it is the thing that would give us something more like a guarantee, and also help us diagnose problems. The whole run of these things, we all care about trustworthiness and safety and bias. And it seems to me that addressing those issues depends on us being able to even characterize what the model is like. And I will say that even though it's a daunting task because these models are so complicated, it's a much easier task than, for example, trying to understand people, because with these models, we can essentially perform brain surgery on them to our heart's content and learn a lot about how they behave in counterfactual situations, and therefore learn a lot about their causal structure in a way that we could never do with another person. Yeah, but here's an example that comes to mind for me. So I think in the very near future, people whose jobs depend on just scheduling, that part of their jobs will disappear because models will just do that better. Absolutely. I mean, that we might currently live in that moment, and it's just a matter of productizing it. So those people are now going to be expected to be essentially relationship managers. And that's much harder work that many fewer people can do. Here's the case that's really interesting to think about. We have a physician shortage. People assume we need to solve it by training more physicians, but it's easy to imagine that we solve it with technology.